Hello, and welcome to our 13th lecture on Java programming for beginners. In the previous video, we talked about arrays. We looked at some interesting things you can do with arrays. We also went further to talk about some of the methods in the arrays class that you could use to manipulate arrays, like the sort method, the fill method, and the binary search method. Now in this tutorial, we are going to talk about two-dimensional arrays. I'm going to limit it to two-dimensional arrays. I know you must have heard many people talking about multi-dimensional arrays in Java, but in reality, Java does not implement multi-dimensional arrays. Java implements a maximum of 2D arrays. Why do I say this? Because when you go into the details and you look at the structure of these multi-dimensional arrays, you end up realizing that it is just an array of arrays of arrays and so on, no matter how deep you go. And instead of going that deep and doing some complex stuff with multi-dimensional arrays or with arrays of arrays of arrays, I think you have better data structures that you could use to handle complex situations. So for this video, we're going to talk about 2D arrays, and we're going to leave it at that. I'm not going to go into the details of all the others, but if you really want to go into it, you can do it, and in the end you would realize that it's just arrays of arrays, and it keeps on going deeper as you want and just makes your life complex for nothing. Alright, with that said, let's see a situation where we would want to use a two-dimensional array. I have a table here. Let's assume that we decided we wanted to take the temperature of our maybe neighborhood, of our environment, wanted to know maybe the climate, how temperature changes over a period of 1 week, for example. So I have a table here. What I'm doing is I take the temperature 3 times a day. I have from Monday to Sunday, and 1, 2, 3, 4, 5, 6, 7. Okay, from Monday to Sunday, and I take the temperature in the morning, in the afternoon, and in the evening. Whatever I want to do with it, not our problem for now. We just want to see how we can store this information in a two-dimensional array. I mean, it's typical that you would want to put that in a table form like this, and that is what an array is. If you are writing your Java program, you're not going to draw up a table with rows and columns like this, but it's going to be better for you to put it in an array. And there's no doubt you have better features that you could use, better features of Java that you could use to handle that. But for now, since we're focused on array, we're going to handle that using arrays. Sometimes you hear people talking about, some people actually refer to an array as a table because it's simply made up of rows and columns if you look at it deeply. Now, well, a 2D array, not a one-dimensional array as we saw in the previous video. So with that said, you'd see I have the same diagram here, this same table that I have up here. I've simply shifted the table down here, but what I have added is that for every column, like Monday, Tuesday, Wednesday, Thursday, Friday, right through to Sunday, I have put in a value representing the position. Remember, we said array indexes always start from 0 to 1 less than the length of the array. So since we have 7 columns in this table, I'm representing each column with with the index position, with an index position, and I'm starting from 0, so it's going to run from 0 to 6, representing the 7 days of the week. Now, each of those days should have 3 different temperature values. 1 for the morning, 1 for the afternoon, and 1 for the evening. And how do we do that? We represent that on our table using rows, like this. We represent that on our table using rows. So the morning is represented by 0, the afternoon is represented by 1, and the evening is represented by 2. And like we still said, like we always say, array indexes start from 0 to 1 less than the length of the array. So you see that this is actually 2 arrays. You have one responsible for each row, and then each row, actually you have the row. Each row is an array, and the row is made up of another array. Like you have a row which is made up of another array, and the array now holds individual values. Now, before we go into the details of how the two-dimensional arrays work, let's access this value. If I wanted to access these values on this table, what am I going to do? I'll say, like, I want to know the temperature for Monday morning. So I'll come to the Monday column, or I'll come to the morning column, and then I'll look at the Monday row. Sorry, I'll come to the morning row, then I'll look at the Monday column, and it falls at this point here, which is 22.3. If I wanted to know the temperature for Sunday afternoon, what am I going to do? I'm going to look at the afternoon row, and I move right through till when I get to the Sunday column, and then I get this 24.4, which is the temperature on Sunday afternoon. Same thing, if I wanted to know the temperature on Monday evening, then I'll come to the evening column, which is which is this one, the evening row rather, the last row that we have here, and then the Monday column. So I'll have 23.2, which is the temperature on Monday evening. And if you see there, I'm representing them. Yeah, let's say I wanted to put in values into this place. I would say the morning of Monday is equal to what? 0, 0. Look at now to see how you actually use two-dimensional arrays. So if we're not using the columns here, the name of the columns Monday, instead we choose to represent them using the index positions for these various tables, for the various columns and rows of the table. So you see that morning of Monday is equal to 0, 0. All of that we are referring to the temperatures table, and the value inside there is 22.3. The afternoon of Monday is equal to what? 1, 0, which has the value 25.3, and the value for the temperature on Monday, on the morning of Tuesday, is equal to what? 0, 1, which is what? The morning of Tuesday, 0, 1, and that's how we access the different components of the table. Now from this, I believe you should be able to make out by now that arrays are actually made up of two-dimensional arrays are actually made up of rows and columns. But then how do we define these arrays, and how do we specify the rows and the columns? We're going to see that shortly. Alright, now remember when we declared a one-dimensional array, we had the data type, we had one square bracket here, we had a set of square brackets here, and then we had the name of the variable. That was the declaration. But now, since it's a two-dimensional array, like in the one-dimensional array, we have just one row and multiple columns. So we use just one square bracket representing the one row that we're going to have. Now, in a two-dimensional array, we have multiple rows and multiple columns. So, the rows will actually hold one array, and like the first one, we are declaring the rows to hold one array, and then this other bracket here, the second bracket here, is another array representing the column values. So you see that two-dimensional arrays are just arrays of arrays, and like we initialize one-dimensional arrays, we also initialize 2D arrays using the new operator and the square brackets with a value passed in. Remember, initially we said when it was a one-dimensional array, we could say daily temperature is equal to new float, and we say 3. In that case, we are defining our array to hold 3 values, 3 columns. But now we also have, it's a two-dimensional array, so it is made up of multiple rows and multiple columns. The one-dimensional array has just one row and one column, so we just specify the number of columns we want in the array. But now the 2D array has multiple rows and multiple columns, so we must specify the number of rows and the number of columns like every table has. So what do we do here? We say new float, same as we initialize a 1D array, but in this case we have a 2D array, and we pass in the number of rows. We are saying we are declaring this array, we are instantiating an array with 3 rows, which is 1, 2, 3 from 0. So row 0, row 1, row 2. And then each of those rows will have 7 columns. The rows will have 7 columns each, running from 0 through 6. And that's why we have 0, 1, 2, 3, 4, 5, 6, giving us a total of 7 columns. So we are declaring an array of 3 rows and 7 columns. And once we do that, we can start putting values into our array by using the index rows, the rows of the index, and the index of the rows and the columns. For example, if I want to put the value 22.3 in the first cell of this table, what do? I use the name of the array. I pass in the index position. Remember, with 1D arrays, we just used to pass in the index and we pass the value. Now this index is made up of, the indexes in the 2D array are made up of a row value and a column. They are made up of a row, position, and a column. So what do? I say row 0, column 0, I put in the value 22.3. I come down here, row 1, column 0, which is this one, I put in the value 25.3, and it's going to go here. That's why we see it fitted here. And then I go here, row 2, column 0, I put in the value 23.2, and I continue doing that every time I want to access a cell. I use the row index and the column index, and I put in a value. Now there are other ways to initialize an array. We all saw earlier that instead of doing this manually, it might be comfortable. We just have data for a week, it's going to be fine. But if we're supposed to take the temperature for an entire year, you certainly don't want to initialize it manually like this. And we're going to see more of that. We saw some of that when we talk about one-dimensional arrays. So we're going to see more of that happening here as we talk about 2D arrays. All right. So now that we know how to initialize our arrays, you see that this is the structure that we have here. But I did something here. Remember, in the previous video, when we talk about one-dimensional arrays, or arrays, simply arrays, we also had another syntax for initializing an array, like where we declare the array and initialize on the same line without using the keyword. And we did something similar to this, except that it was a 1D array, so there was just one square bracket here and just one value here. But you see that this table structure could be created by doing what I've done down here. I declare, I'm saying it's a 2D array, and I specify. Now I don't specify the number of rows and columns. Why? Because when I put in the value, the compiler is going to be able to read the values inside here and know exactly what size this array should have. And that's why you don't need to use the new keyword on it anymore. So I'm declaring an array. You see that it's actually an array of arrays. That's why I said earlier that there's no need for us getting into 3D arrays, 4D arrays. That's just some unnecessary work that you want to do. But from these, you can clearly see that a multi-dimensional array or a 2D array is just an array of arrays. We have the principal array outside here, which is the main array, and then you have 3 different arrays inside, specifying each row, and each of the columns here can be accessed using the row and the column index. We're going to see that in action shortly. So with all of that said, I'm going to take this away, and I'm going to bring up my NetBeans so that we can actually see it in action. All right, I'm going to open this, and I'll just create a class here. I'll not use the old class, we have overused it, and there's so much junk in it right now. So I will say 2D example. I call it 2D example or 2D array example. 2D array example, and I'll save that. And since inside my class, I would write a method public void demonstrate. And in my demonstrate method, what's gonna happen is, I'll close this for now, we don't have an output. In my demonstrate method, I'm going to declare an array public void, I'm going to declare an array, not create a method again inside the method. Please don't do that, that was a mistake. I'll declare an array daily temperature and it's a 2D array. What am I doing? We declare arrays to be float daily temperature, and just to show you something, I'm going to come here. If I say it's a 2D array, I'm sorry. Alright, that's my 2D array. So I'm going to come down here. Same with the one-dimensional arrays. If I do this, like I've declared the array and I want to put values inside. For example, and then another array. I separate the other arrays, all the internal arrays with commas. You see that I have an error. Like I said, once you're using this syntax, then you must initialize and declare the array on the same line. So if I cut this out and I paste it here instead, like this, then I should not have a problem. But if I'm doing it on a different line, then I have to use the new keyword. That was just as a reminder. So I'll come down here and I'll say daily temperature is equal to new float 3 and 7. You see, I'm saying that my array should have 3 rows and 7 columns. That means each of the rows should have 7 columns. And I can now come inside here. I'm just going to initialize maybe the first 2 and print it out. Oh, well, I'll initialize it in a loop. I could say for int I is equal to 0. I is less than so I'm gonna say I is less than daily temperature dot length, which is the number of rows, since the outer loop is going to control the rows, and I plus plus, and inside here I'll put another for loop to go through the individual columns of every row. So I'll say for int j. You could nest any kind of loop. I'm just using a for loop because that's the first thing that came to mind. So you can go ahead and use any kind of loop you prefer. So I'll say j is less than daily temperature, j is less than daily temperature 0 I. So now that entire row, I'm taking the row. For the case 0 is going to be the first row, which is also an array. Then now dot length of that array, and I say j plus plus, and I go inside there, and now I would initialize my daily temperature array. I could say daily temperature I, which is the row, and then j, which is the column for the current row, is equal to, I'm just going to say I times j. You could put anything, or you could put, yeah, I times j, whatever you choose to do. Plus 24 or plus 20, whatever you choose is fine. And I'm just looking for a way to get a value there, since I don't have the actual temperatures to put inside there. You could do anything. If you want to put zeros in all of them, fine. And then what I'll do is, to make us see what actually happens, I'm going to print out the array after we have initialized it. I'm going to come down here, and I'm just going to change these to system.out.print, and I'll print this portion, and plus, remember, I'm just concatenating some values here to make the thing look presentable. And the value of j, and is equal to this. I need to close this here, and there's something missing inside here. This plus this plus this plus that. All right, and I'm just going to, after printing the values of the first row, I'm going to break to a new line and print an empty line there so that it breaks it. And if we run this, all right, okay, I'm calling it here new 2D example dot demonstrate, which is this method that I have here. So if I run this, there we go. Let me make it look a little nicer by adding some blank space here. Oops, where was it? Here. And if I run that again, now we see our array quite presentable, right? Like that. Exactly what we wanted. And those are the values we've got. So with that said, I think it's pretty straightforward. And that's it about two-dimensional. Alright, now that we very well know how two-dimensional arrays work, I want to show you one last thing. I'm going to comment all of these out, and I'm going to print out the length of the individual rows that we have in this array. So I would say 4 int x is equal to 0, x is less than the length of, is less than daily temperature, the length of the daily temperatures array. In this case, when you're using just the name, you're referring to the number of rows in the array. And I'll say x plus plus, and then I'll print out the length of the individual rows. The print line, and I would say daily temperature. I'll just copy this. And I'll paste it inside here. And that should be x plus the closing square bracket plus some string saying is or has daily temperature dot length, daily temperature x dot length columns. All right, that's pretty simple, I guess. So what I'm doing here is I'm looping through this array, all the rows, and for each row I print the length of the row. So if I do that, you see that daily temperature 0 has 7 columns, daily temperature 1 has 7 columns, daily temperature 2 has 7 columns. So all of them have the same number of rows. The number of rows is fixed. But then there may come a time where you want an array, where a multidimensional array where the number of columns for each row varies. And how do you do that? You can simply take off the number of columns. Now once you do this, you're saying that I want an array with 3 rows, a 2D array with 3 rows, but I would later on specify the number of elements to put for each row. Like I'll later on specify the number of columns for each row. If you run this without specifying this, if you don't specify this later on, you're going to fall into trouble. So I could now initialize I could now declare or instantiate each row to have its own specific number of columns, and I could say daily temperature 0, for example, is equal to new float, and now I'll say this one has 30 columns or 39 columns, whatever, and I'll do the same thing with the other 2 that are left. And maybe I'll say this one has one has maybe 10, and this one has maybe 112, whatever. And now if I run this again, you will see that the number of columns that each of these items can hold is different. I have an error. Oops, 2, not 1. Yep. And you see that it's pretty straightforward, right? Now you see that the number of columns vary, but please be careful. The number of rows can never be left out. If you leave it out, you're going to have a problem. You see, you must always specify the number of rows at least in the instantiation of the 2D array, so you can do a little more with that level of flexibility that you have there. And with that said, that would wrap up our tutorials on arrays. Later on, as we go through, we'll talk about other data structures. We'll look at sets and how to better handle things. We'll talk about that later. So for now, just practice more on this, and I'll see you in the next video.